question. It says that a PET sample with 40% crystallinity shows a melting endotherm in the first heating cycle of DSC with a melting enthalpy of 50 joule per gram. The degree of crystallinity of another PET sample in percentage, which also shows a melting endotherm with a melting enthalpy of 80 joule per gram. So how we will do with this question? So there are two PET sample. For taking with the first PET sample, if we talk about the first PET sample, then it says that the crystallinity that is given is 40% and the enthalpy is given as 50 joule per gram. And for second PET sample, the crystallinity we need to find and the enthalpy is given as 80 joule per gram for second PET sample. So how we will proceed with these samples, since as we know that both these samples are PET samples, means polyethylene terephthalate samples. So if we say that these both samples are of same fibers, so if we say for 50 joule per gram enthalpy, the crystallinity that is 40%. So for 1 joule per gram, the crystallinity would be 40 upon 50. And if we talk about 80 joule per gram, then the crystallinity is 40 upon 50 into 80. If we solve this, then it comes out to be around 64%. Then the crystallinity in percentage is 64%. This is the final answer that we need to calculate. So the crystallinity in percentage of another PET sample, since both these are PET, then these are both are of same quality. So if we need to find out these things, then it can be solved it accordingly. So the answer is 64. Now coming to the next question, it says that if the twist multiplier in the indirect system is 4.8 TPI per NE, then the twist factor in the direct system TPM root text rounded off to 2 decimal place is. Then how we need to find out this? Here what it is given as, this is a yarn manufacturing question. This is a 2-mark question, and if we have to calculate how this we need to do, then the TM that is given as 4.8 TPI upon root NE. If we have to convert this into the direct system, that is text, then how we will this per inch, TPI is twist per inch. So if we have to convert this into direct factor, then this is 4.8 twist per inch. If we need to calculate into meters, then it is 1 upon 39.37 meter into this NE is if we need to convert this into text, then what it would be, you know that text is equal to 590.5 upon NE. Then how we need to convert this? For NE is 590.5 upon text, 590.5 upon text. So if we will solve this, then it would come out to be 4.8 into 39.37 into under root of this is 24.3. If you will calculate this, then it would come out 39.37 into 4. If you will do this, then you can do this by using the gate calculator. Then if you will calculate, then it would be come out to be 188.976 into 24.3. Using gate calculator you can solve this. It would come out to be twist factor is 4592.11. So this is the correct answer, and the gate that the official answer was accepted in the range 4591 to 4593. So this is the official answer key, and this is the correct answer that you need to calculate. This is a 2-mark question. Now we will look on to the next question. This is also a 2-mark question. It says that a plain woven fabric with 20 ends per centimeter and 30 ends per centimeter prepared with 30 tex warp yarns and 25 tex weft yarns. Neglecting the yarn crimp, the areal density in gram per centimeter square of the fabric is. This is a fabric manufacturing question. Here we need to find the GSM, gram per square meter. So if you know about the fabric areal density, it is basically the warp areal density plus weft areal density. So if we will calculate this, then for W1 it is saying that, means for warp it is saying that EPCM ends per centimeter is 20 and tex is what, 30. So how we will calculate this W1 means weight in gram per meter square. You will calculate 20 ends per centimeter, it is given as, and the tex is given. Tex is basically gram per 1000 meter. So 30 upon 30 gram per 1000 meter. So this per centimeter into meter, if we have to calculate this into 100 into 30 upon 1000 gram per meter. 0 cancelled. This comes out to be 60 gram per meter square. Similarly, if we will have to do for this, if we need to calculate this, then we can say that for next W2 calculation, then how we will do the W2 means W2 calculation can be done by, we can solve this. W2 in gram per meter square is basically 30 pics per centimeter into 25 gram per 1000 meter. So it is W2. These values are given. So how we will calculate 30 upon meter, if we will convert per centimeter into per meter, it is 100 into 25 gram per 1000 meter. So if you will calculate this, then the answer will come out to be 75 gram per meter square, W2. Then the fabric areal density, if I talk about, this is W1 plus W2, it is 60 plus 75 gram per meter square, it is 135 gram per meter square. This is the final answer that we need to calculate. So 135 is the answer. In integer we need to write it down, then we can say that it is 135. So this is the final answer.